Okay, everybody. Hello and welcome to with Cocktails for the Plotting Experts, Whiskey with Whales. It's February 19th at 4 o'clock Pacific. And we're going to take about an hour's worth of questions, both here on Zoom and in the testnet channel. Also want to make sure everybody's aware that RC2 is out. Please do upgrade to it because I bet that the beta 27 chain will die a horrible death very shortly. But with that, let's open it up. How about a quick intro to the level you're comfortable? Obviously, not a whole lot necessary, but just how'd you get involved? What do you do? What's your background, sort of?
Yeah, I guess I can kick it off. So many of you guys know me in the chat as Storage JM. My name is John Michael Hands. I'm a product manager at Intel. So my day job is managing the product line for Intel SSDs. So obviously when I heard about a storage cryptocurrency, I'm like, this is interesting. I need to look into this. Unfortunately, when I first looked into it, like in 2017 or 2018 was like the first article about Chia. I waited a long time. I kept trying to see if it was launched yet. I finally caved and downloaded the Keybase, I want to say like in July, and installed the alpha. And I ran my first plot, and I was blown away because I measure endurance for SSDs, in the lab and stuff. And I looked at the plotting, workload. And I'm like, wait, did that really just write 6 terabytes of data to make a 100 gigabyte plot? I was just floored. I've never seen anything like that in my career. So I was just so interested. First couple of weeks, I was taking kernel traces, just digging into the plotting workload, kind of looking at it like a black box. I'm like, I was trying to deconstruct it. I'm like, I'm going to figure this out and crack the code and, figure out the most efficient way to plot. And so I did it the way I know how to do it, which is kind of like deconstruct it from the storage standpoint.
Cool. Michael, Xerox?
Yeah, my name is Michel Erb. I go by Zorinox for forever. Whatever you search on the net, that's under my name. I'm a lot of things, but I'm a biologist and a computer scientist, and I've always had jobs in that space, doing computer science, software engineering for labs, supporting science research. I got involved with Chia a little bit before, with failing getting anything out of burst. I learned about Chia, and then I came back to the Chia website like once a month to see if there's anything posted that you can try and test. You happen to be on your website early last year. I think you just got rid of MongoDB from the stack, installed it, and I joined the community and started to ask questions, and started plotting. And there was a person that originally made me aware of those terabytes that are being written when you're plotting. And that was early spring. It was a bit of a shock for everyone.
Was different.
Yeah,
Derek.
It has improved a lot.
Yeah, it has. Derek.
Oh yeah. Can you hear me well?
Yes, great.
Yeah, I'm on the forum, Farming 101. My background's got absolutely nothing to do with computers or computer science whatsoever. I specialized in process development for a company called BHP all my life. I was the manager, or the technology development manager for hydrometallurgy and chemical engineering. So yeah, my life's work was about environmental processes, designing and implementing more environmental friendly mining practices. And I've done 6 or more patents on that, and 20 or more international papers. So really nothing to do with computers and so on. And I stumbled upon Chia basically as a way to add value to energy. What I wanted to try to do was to run like a house or a small business, basically costing no money. And the only way I could do that was by having a value add component to a renewable energy installation in the house. And I tried the mining process, but the energy balance didn't work. It didn't scale very well. So I stumbled upon the POC cryptos, which burst was not a success. I couldn't latch onto the project, and then stumbled on Chia 2018, and then just started with it. And I was the first farmer on Alpha 1 outside the developers.
Great. Hamish.
My name's Hamish, better known as H or Kiwi H. I'm a convert over from the Burst PhD mining over to Chia. Got involved in disk-based farming mining because it seemed like a much better way of doing it than proof of work. And I've been kind of caught the bug and been doing it ever since.
Just to note, we are at capacity. As I said, I tried to get the YouTube live stream to work, but we unfortunately have not gotten quick enough response from Zoom's team. We'll try to keep this, flowing across, and maybe Cytoflake and others can, shuttle questions back and forth. Anyway, and there's this one other person who just showed up. But who's this? You're muted, Bram.
Are we recording?
Yes, we are.
Okay, good.
I was teasing you. Who are you? Just a guy asking questions. Okay, so let's get into it. What are the primary bottlenecks to effectively plot Chia plots?
Everything.
Yeah, this is the most fun about Chia. They're like, well, I'm going to change one thing, and it's like, well, you need CPUs, and you need to scale the amount of CPU cores per the number of threads and processes. You need a certain amount of fixed capacity for temporary space, and it needs to also be fast. And by the way, if you have a big drive, your SSD has to also support a high bandwidth, because you need to support a bunch of concurrent bandwidth. You also need a bunch of DRAM, because the DRAM scales per process. So it's really just this multi-dimensional puzzle. And we're looking at different CPU types and different CPU instructions per core and frequency, different types of storage mediums. I don't know, we got a lot of questions in the chat about SATA versus SAS versus NVMe, and there's so many different ways to attack the problem, which is interesting. So it's fun, as you've seen, Zornox and myself and folks here, built just about everything. I have, I work at Intel, so I have desktops, stacked to the roof in the garage, about every type of Intel CPU, and we've got servers, we've got all kinds of different stuff to test. So it's cool to see lots of different approaches been successful. I think we'll talk a little bit about that today.
Yeah, I think that's actually a perfect lead into the next kind of question, which is I think each one of you have somewhat come at the problem slightly differently. So I'd love to hear kind of each of your takes on, how you went about it, possibly why.
Just as, my thoughts are more background than anything else here. The algorithmic problem of plotting is it's a fun thing to work on. It's very, very different from the normal things you worry about in algorithms in computer science. There's a few notable little quirks at the edges of it. The biggest thing is it's optimizing over number of passes over the data. And we're actually using some techniques that I suspect aren't in Hadoop, and would probably make Hadoop run a lot better if it was. And we're doing a whole bunch of sort passes, and actually we're doing this sort, this bucket sort in memory, which even our non-parallelized implementation of it is a lot faster than the normal sort functions, which is weird, but it only works on really, really nice smooth data. If the data is at all not smooth, it just fails miserably. But our data being cryptographically generated is perfect for this, but that's sort of an interesting thing to note. There might be many real world data processing things where actually bucket sort would perform better, depending on distribution of keys and such. We still haven't finished our optimizations. We did all these, we had this long sorted history where we had a competition for improving our implementation of it. And we actually put together a bunch of notes about how you could go about improving it. And that competition mostly failed. Well, in a few ways. So people did manage to get a little bit of speed improvement, but they didn't really do any algorithmic optimizations to number of passes over the data. And they didn't really, and they didn't change the format at all. So there's optimizations that can be done to the format to compactify things more that we're expecting to be implemented reasonably in the future, but we're not working on right now. There's basically 2 of those we're thinking about. But then for the just minimizing the number of passes over the data, which is this really super weird and interesting thing, that when we have gone and done optimizations, and we got like basically like a factor of 3 speed up from all that, I think, after we did it ourselves. We're getting to the point now where the optimizations like that are a lot harder to do, and their trade-offs are more ambiguous. It's like it might help under these circumstances, it might hurt under those circumstances. It's complicated. But we have more of those likely in the pipeline. I'm not expecting another factor of 2 improvement in speed from algorithmic improvements in it. And I'm not going to be the one implementing it. Probably after we launch, Arvid is going to go back to working on those sorts of things. Yeah, but it is at the point, like you said, that there's all kinds of complicated trade-offs that happen. You're really trying to make it be that you're limited by bandwidth, but you can also be limited by CPU, and you have issues with how well you parallelize across all of your CPUs, and then you have to worry about whether you're destroying your SSD by doing more writes than you have to it, and there's also just like cost versus latency on this stuff, right? Like you can do plotting on a physical HD. It's slow, but it'll work. So, you know, if you have enough of them, you could do that as well. So it gets all complicated, but we will have more algorithmic improvements in the future, not nearly as dramatic as the ones before. That we got it working well enough that kind of stuff got lowered in our priority list.
So again, let's go back to, you know, what each of you kind of approached it with, because there are some different kind of overall approaches that you're taking.
Well, for me, I realized early on that sort of NVMe was going to be the fastest, but to get to the scale I wanted, NVMe just wasn't an option for me. In the work I do a lot of work with servers. So I went with a server-based approach, SAS SSDs, multiple parallel, go wide rather than go fast.
Yeah, it's interesting. Like, you know, my gut feeling said that, you know, a desktop would outperform. You know, I have, you know, done like the top of the line Intel, you know, i9, 10, you know, like, you know, 10, 18 core, you know, max CPU clock speed. And those, you know, produce really fast results, but then it's much harder to attach a lot of IO to a desktop. And that goes back to a server, where a server has been designed to have, you know, serviceable, accessible storage. It's designed to have a lot of it. And, you know, going back to like practicality, I had my fastest plotter was my i9 desktop, but every time I put a new component in there, I had to reset the CMOS, and I had to reset the entire OS, and it was just such a pain in the ass. Servers are meant to have, you know, a bunch of different cards attached, a bunch of different, you know, storage and IO performance things. So yeah, I went from desktop to server, and I have some desktops in the house that are plotting right now, but at the end of the day, you know, servers are designed to be running 24/7, be running sustained workloads, be running at max CPU utilization at all cores, be running thermally efficient. They have fans that are designed to, you cool all the components, and, you know, you can't beat with these, you know, servers that have 24 2.5-inch bays for trying to, you know, support a lot of drives. So yeah, there's going to be a bunch of different approaches work, especially depending on people's budgets.
Yes.
Michelle?
Yeah. I have early in the, when I realized that there are a lot of templates, I also decided that the NVMEs is not the right thing if you want to do more plots than a couple drives full, because you basically, for every couple drives you buy, you have to buy a new NVMe drive, unless a consumer grade at least. So I've looked for alternatives, and I've actually benchmarked and compared how much faster is the NVMe drive versus a SATA drive, a SATA flash drive, and there wasn't that much of a difference. Mm-hmm. So for a single process and a single plot at a time, obviously with an NVMe drive that has very good sustained IO, you can scale multiple processes on it, but it's still, once you want to have 4, you already need a large NVMe drive, which is pretty expensive, for the same amount of money, you can buy used data center grade SATA flash drives. It's just a completely different build. So I have done a lot of work in the HPC space, and when I really saw how much I/O, how much compute and processing that's happening, it's a high performance compute application. If you want to do this beyond a couple dozens of terabytes. So I have designed my desktops in ways that I can fully utilize every single PCI lane to the max, and have, for example, not purchased 12 or 16 core CPUs. I stayed with 8 because then I know I only have that many PCI lanes. I use them all, and I buy another computer. Now, if you're in the server segment, you could do the same. Maybe you have a dual socket system. It's a way. You have to decide also, considering budget and space. I'm in an apartment. I can't have a server rack anywhere here, really.
I can.
you have to decide how much do you scale up or how much do you scale out. And I took the scale out approach. So I have many machines that are built similarly with up to 24 SATA drives, and get really great results.
Eric, what was your take?
Yeah, the first machine that I bought, was the i9 900K, and similar to what you guys said, is at the end of the day that desktop is a gaming machine. It's fast, single core, but the disk I/O is restricted. So as a non-computer person, I didn't know anything about servers, so I took a completely different approach. I built lots of small computers, 4-core and 6-core. So with that, they were cheap. You could build a machine for $150, right? And it's mostly 9-100 and Pentium 5 400, 6 400s. The single core is pretty good for the price you pay on it. So I just built 16 of those. They can run 4 plots each, and there's no restriction on the I/O. You don't need to try to balance the plots or wait, try to synchronize stuff. You just pretty much press play, and the thing can plot 16 terabytes a day, and you don't have to worry about it. They are still the same as when I started. They're still running, never been down. And from the addition of the Intel enterprise drives, that made it even better, right? Because now you add endurance to that, and yeah, those things are great. Each one has got a little screen on it, and I can just go for it.
We don't mean this to be an Intel ad, but it is, and it should be. I just want to add one thing for people who are just tuning this to replay or just tuning in right now. I'm the shrimp in the room, and I've just got a 3-year-old iMac and a nice USB 3.2 external, and I get 9-10 hour plot times, and I string it together and let it run forever and slowly but surely fill up plots. So it's not like you have to go here, but if you want to get high throughput, this is the way to do it. Let's talk about how much used factored in. I think, that was kind of came up. What else are you guys thinking about used? How has used hardware been part of what you guys are doing?
Well, I can tell you, it brings joy to my eyes seeing all these hilarious, all the drives I worked on 6-7 years ago that are showing up on eBay that people in the chat are asking me about. And people are DMing me with like, this is some weird firmware I see on this drive. I'm like, oh my God, I remember this like weird bug like 7 years ago, but no, the thing about SSDs that I think people forget was when Flash every year, like Flash was really good every year. They try to reduce the cost. So, every year SSDs get cheaper, and the challenges of Flash moving from, 2D NAND to 3D NAND and then scaling the layers, sometimes in that big transition came at a trade-off, when they went from MLC to TLC and TLC to QLC, consumers just don't need a lot of endurance and a lot of performance. Cost was king. And so in the last, 10 years, that's mostly what the SSD industry has been optimizing for. Now, the SSDs have been getting faster as well, and then I'll talk a little bit about NVMe and some other stuff, but those drives that are like 5 or 6 years old, the first NVMe drives that launched in 2014 are absolutely a beast in endurance. They just don't make drives that are 25 and 20 drive writes per day anymore. It's like those were just way overkill for the workloads. And people have gotten much more sophisticated in being able to model endurance and think about actual drive wear out. In the beginning of the industry, people were so scared that SSDs were going to wear out that they overbought endurance. And so some of these old drives are actually great. It's funny, people buying old drives that are 5 years old with like 80-90% endurance left on them.
Anybody else on the U side? So let's flip to, some people walk up and go, hey, I'm going to use NVMe. And we've kind of talked about it, but what should people be aware of when they're thinking about using SSD as temporary plotting storage?
So let's be clear. I mean, SATA is dead. The last SATA speed improvement was SATA 6 gigabits per second. It was, I think, 10, 11 years ago. And the entire industry, meaning the people that make SSDs and hard drives, got together and said, okay, is there going to be a SATA 12 gigabits per second? And the answer was no. You had SAS, which is for enterprise. And that's one of the questions we get a lot in the chat about SAS for SATA. SAS is specifically multi-host, multi-device. It was meant for these large topologies of JBODs and cascaded JBODs, many disks, being cascaded from servers, where SATA is very single host, single device type of application. But 10 years ago, the industry decided, let's go to NVMe. We'll use PCIe to go, drive that performance scalability year over year. And then NVMe was the new protocol for SSDs. So now that the price of NVMe drives and SATA are basically the same, buying a new drive, no consumer would really be interested in SATA, besides the fact that it's very easy to hook up. Because it shares the same interface as hard drives, you have a 50-cent cable that you can hook up a bunch of drives on a desktop extremely easily and cheap. I have like a PCIe cable here for a desktop, right? This is like a $15 cable on Amazon, to connect a U.2 drive, U.2 NVMe to a desktop. And it's $15 versus a SATA cable that's 50 cents. So that's the whole point of SATA, is it's cheap, easy, everybody understands it, but there is no future of SATA. It's a dead roadmap.
Great. So can somebody talk about the ratio of RAM to number of cores and how they relate to number of buckets in parallel versus queue?
Any takers?
Yeah, H want to take it. Michelle want to take it?
I think Go ahead. I just wanted to say that I think the one guy that figured this all out is actually not on the panel here, PYL. He has posted there's a very good description, and I'm still just following that. It's in one of the discussions. The title might be a bit misleading. It's something like the crazy new plotter or something like this.
Yeah.
But it's basic. I've been following this forever, and I have not played much around with it. But I think Heich, you have some more details.
Yeah, a caveat about any numbers here is our implementation still probably kind of sucks. So there probably are, like if you see something where like adding more cores past a certain point just isn't helping, entirely plausible that like, that's just a software issue. And if something was changed, that could improve that. And there's all kinds of weird deep voodoo when things are bottlenecked on throughput. You always want like the CPU running while throughput is happening, and you don't want them to sequentially wait for each other. Getting that to work right is deep magic, and we probably haven't done it super well in lots of places in our plotting software.
Yeah,
I've commented on that many times. This is very, very, very hard. This is the core business. This is the core business of any database vendor or open source project, is how do you get the cores play perfectly well with I/O?
Yeah, and generally, like in many databases, like a MySQL instance, they're very dependent on DRAM for the I/O. So the fact that in this case, in plotting, you're doing so much writing, you can't really take all the advantages of some of the modern database performance, which is actually tuned for read and analytics and all that stuff that is mostly read heavy. Yeah, it's really interesting. We, for the DRAM, when I took a kernel trace of the plotting very early, basically the way it creates the temp files, and then it dumps those onto the drive from DRAM, and it happens basically all at once. So there's a big spike at the queue depth of the SSDs that are basically writing all those temporary files to disk. And then when those are done, the plotting process cleans up those temp files, which happens on the SSD. It sends trim commands to those to the SSD that corresponds to the LBAs of the temp files. Some SSDs handle that really well, some do not, right? And that's why people see a lot of variability when you have these massive amount of file deletes happening all at once. Some of the older drive models the firmware does not like that, so there's a huge variation. Again, people using all kinds of different types of hardware, but
it's interesting because we could compensate for that in software by like not deleting files, by reusing sections of the same file instead of
that works too. Like there's a like enterprise, well, I would say hyperscale database like RocksDB that like Facebook uses for all the graph databases at Facebook. They actually rate limit the trim going to the drives because they know about this IO, discard. If the more trims you send to the drive, the higher the latency is going to be. Now, the thing in the plotting algorithms is you don't really care about latency. You're just really caring about disk bandwidth. You don't care how fast you receive the IOs in the temp file. You're not caring about a quality of service or latency. You just really care about how fast can you get those to disk. So you're really optimizing for something a little slightly different. But
yeah, well, it's all weird because you don't care about the latency. Well, you really don't care about the latency on your writes. You mostly don't care about the latency on your reads as long as they're coming in as fast as they can. Because you can kind of say, here's a whole bunch of things I want. There are places in the plotting process where you're like reading from one or two files simultaneously and writing out to another one at the same time. So the drive is going to have to be flipping between reads and writes there.
Yeah, and some drives, like the data center drives that are tuned for mixed workload performance, will handle that much better than like consumer drives, which are much more read oriented and have caching algorithms and are not meant for like heavy sustained write workloads.
Yeah.
The other thing, to take advantage of SSD performance, SSDs are inherently parallel. Like you have a SSD controller, you have a bunch of die from the NAND die that are basically in packages on the board. So the way SSDs get faster is you do reads to multiple NAND die at once. So the higher the queue depth, the more parallelism within the drive, the higher the performance. And this is why you see when you have increased plotting, processes, when you have one, you're not going to see a huge difference between a SATA drive and an NVMe. But when you throw 15 plotting processes at a drive, if you had a high capacity SATA drive, it would be severely bottlenecked by the interface, where an NVMe drive, you must see how much higher bandwidth because it scales by the number of queue depth. So yeah, there's definitely, in that question, that's another question we get a lot about SATA versus NVMe. It's all about the size of the drive. Like as Zornock said, on a 480 gigabyte drive, it's not going to matter, right? You're doing one plot, the plotting algorithm is not, IO bound. But if you're doing 16 plots to a drive and it's an 8 terabyte drive, you are absolutely going to be IO bound if you're on a SATA interface.
Right. There's other weird hinting that like one drive won't let you do, but if you have multiple drives, because we have this like multiple passes thing, we could implement it so that the workload would plot balance between two drives, and the workload would be it's always doing a whole lot of reading from one and a whole lot of writing to another at the same time. That could potentially optimize better, maybe.
Yeah. The other thing, is the whole staggering thing. Because it's only phase one that's multi-threaded, people have tried to figure out the best ways to basically get max CPU utilization of the plotting process by running high number of threads on phase one. When that's done, starting off another process, and then kind of escalating from there until you have it filled up. But that's really not the best way to approach it, right? If you had other threads multi-threaded, then you would not need as much temporary storage. You'd need a much smaller capacity SSD if you had other phases multi-threaded.
Yeah, we don't really know how to make our other phases multi-threaded. There's less brute computational work they're doing, but they are doing like a lot of sorting and stuff. One of the biggest issues is that bucket sort thing I said. It's hard to parallelize that, but that thing running mono-threaded is faster than multi-threaded normal sort. So, so that's what we're doing.
So let's talk a little bit about economics. Just for simplicity's sake, let's kind of throw out that you've got hardware that exists, and I'd pause and say, start with the hardware that exists when you're trying to learn to plot. Don't go out and buy stuff yet. But give people a sense of like how much do you need to spend to get to what like terabyte output per day.
If you guys are following the chat, I just built it. So I just moved into my new house, so I finally have a garage where I can build stuff again. I had this sitting in my garage, which was just a 10th gen Core i7 and i7 10700. I cheated because I get it from Intel for half price. So I a little cheating, but there, say this is like $250 on Micro Center. This thing, with just a 4 terabyte SSD can do 3 terabytes a day of plotting, and that was fully optimized. That's pretty good. That's like a sub $1,000 machine. My highest rated machine, if you go to the wiki page where we posted all our machines, I have a dual 18 core server with 256 gigabytes of DRAM and massive amount of SSDs in there. That's doing 7 terabytes a day. So it's hard, right? Like you can get better economics by scaling a lot of desktops, but servers, they're in a rack, they're nicely organized, they can all be automated. You can remote desktop into them. It's much easier to manage servers being ran 24/7. You can get very good economics on a desktop. It's just harder to manage like many of them.
And if you're going for servers, used servers make so much sense. Yeah, you get a used Dell 730 or a Gen 9 HP and 24 plots going at a time, 48 plots going at a time. They're not as fast as anyone else's, but you get the number.
Just so to iterate on that, the server refresh cycle is happening soon. Intel and AMD are releasing new server CPUs this year, and a lot of people will be getting rid of their existing hardware. So there'll be a bunch of Xeon V3 and Xeon V4 flooded in the market this year from people selling them. You can already get a 14 core Xeon V4 on eBay for $120. And so if you get an older server and you're comfortable building an older server, you can build a very high performance plotting machine out of an old server. Either by buying a used L1 or building your own based off Supermicro or other components. But yeah, there's really not one size fits all solution for this plotting problem.
No. Yeah, even the company we're buying used enterprise pull out hardware because it's like we want to have a test net support of 500 terabytes, but why spend a bunch of money?
Well, that 14 core CPU when it launched was $3,000, and now it's $130 on eBay or whatever it is, right?
Yep.
I was glad to see we converted you to the cult of Micro Gene.
Yeah, we're going to use Supermicro, just straight up. Storage JM hooked this up, so we're all set.
Yeah, yes.
Good. I'm going to be racking hardware in the next week or two.
I have servers that I bought, like the Intel reference platform servers, and I have ones that I bought from Supermicro and built up. And when you're building servers, just things are weird. Like you have to seat the CPUs right, and sometimes the DRAM slots on my Supermicro board, like 2 of the slots didn't work with one DRAM, but they liked this other one, and so it's just desktop. A lot of people are comfortable building desktops. So in the chat, I'm like, don't go out and buy a server if you've never built a desktop. Like if you're comfortable building desktops and you can build desktops back and forth, that maybe that'd be time to go build a server from scratch. But it is a little trickier, for sure.
So I have 2 quick questions and then a much more involved question that's related. Question number 1 is, Bram, everybody wants to know what you're drinking.
Oh, I don't drink very often, so I don't have a lot of alcohol around here. So I was a minute late because I was scrounging for stuff. So right now I'm drinking rye with vitamin water as a mixer. So.
Okay, and not related, but related. Why would you plot larger than K32? H will answer if you'd like.
Yeah. So a lot of this has to do with support for the future. That we have formats that are supposed to last until the end of time. So I could envision a situation where at some point in the future, you have like a 3-dimensional crystal storage on your home machine that has, I don't know, a zettabyte of capacity or something like that. And the sheer number of reads that are going to have to happen if that thing is all split into K32s is going to kill it. So I'm not particularly advocating anyone do greater than K32s just yet. We did manage with the new consensus algorithm to really limit the need for anything larger than that. But decades or centuries in the future, who knows? And so that actually reads directly into the last question, which was like, how and why would we make a decision to not have K32s? That basically if grinding becomes economical, right? So there's kind of everything is supposed to bottleneck on on CPU, or not on CPU, on a disk that you're just supposed to have, normal hard drive sitting around. So things we don't want to have happen are people getting a whole bunch of tape drives and using those because those wouldn't really be very useful for anything else, which is not what we want to have happen. And then we also don't want someone having a rig which, instead of having a whole bunch of plots sitting on drives, regenerates a whole bunch of plots really, really fast whenever challenges come in. Now, we're quite a few orders of magnitude away from that being economical right now, which is a good thing. But in principle, if that does become economical, we might crank up the minimum K in order to stop that from happening. At the moment, given the way everything has planned out, we're basically anticipating, unless someone has a differing opinion among you guys, my expectation is people just kind of stick with K32s for the next couple of decades.
My big question is like, so I think the way I understand it is you have to complete all of phase one before you know if a plot's going to pass the filter.
Yes.
Right. Yeah. Okay. So basically your bottleneck is going to be how many cores can you throw at phase one, and if you can complete that before a signage point.
Well, no. There's this factor of 512 filter, which you can check immediately up front. So that was a direct trade-off. That's a direct trade-off. That it's a linear thing where the fewer lookups you have to do, the more advantage someone trying to grind is. Right.
Yeah. So we had to trade that.
Yeah, but then there's just that factor. But if you want to know the actual quality of your thing, where if it does pass that filter, that just gets you a factor of like 512. If it does pass that filter, you then need to basically
create the whole
complete all of phase one to find out if the actual responses you get are of any reasonable quality.
Before the signage point completes.
Yes, the 30 seconds.
Yeah, okay, I get it. Yeah, so it's really
not before the signage point completes, before the infusion point happens. So that's like a 30-40 second.
Okay. Yes, it's a really hard computational problem to crack if you're trying to attack, if you're trying to be an attacker.
That's right.
Yeah. We feel pretty good about it right now, and that's partially because I spent most of last year on our new consensus algorithm. This was one of the things we were optimizing for. It did a lot of really, really complicated trade-offs there. I think we've hit a pretty good sweet spot for them.
Okay, so here's a fun one. What's the difference between a TIB and a TB?
Oh man, tebibyte versus terabyte.
1.2.
Yeah. So yeah, it's funny. People thought as simple as like, oh, and an 8 terabyte drive, is like actually 8 terabytes, but it's not. The way that these device manufacturers do the label, there's 2 specs. There's one called IDEMA, but basically they try to make the number of LBAs 4K aligned so the file systems don't just throw up. And so it's not exactly 8 terabytes, but the big change is, device manufacturers list the drives in terabytes, and you'll see on Mac OS and other operating systems, they use, in decimal form for the terminology, but in many operating systems like Linux and Windows, they use GIB and TIB, so gigabytes and tebibytes, which is 1024 divided by, not by 1,000. It's not decimal, it's binary. And so I have a nice little calculator I put up on the wiki page that has, for every capacity drive, what the actual capacity is going to be in the operating system, how many plots you can fit on it for temporary storage. We've done all the math. It's somewhere up there.
So, one of the questions I want to ask all of y'all, but first I'll preface it with everyone here placed very highly in multiple of the farming competitions. So they have proven that they have that space kind of indirectly. Who here is a little sad they overspent on plotting and didn't buy enough storage?
Well, now that we're racing to mainnet, I'm happy I have the extra plotting power, but
I already had the storage, so it wasn't a problem.
Well, we'll just say we were all planning for a December launch, so we had everything set up perfectly, and like the number of terabytes and rack. I had my rack perfectly fit where every single drive was full and everything dialed in. And I'm like, oh, now I'm gonna have to rip the whole thing apart. But no, we're all excited. I do have the T-shirt, Gene, somewhere packed up in my boxes here when I move in the move.
Perfect.
I have my farming OG t-shirt.
Yeah, sorry everyone, we didn't manage to launch mainnet in December. In the interest of getting mainnet out as quickly as possible, we're actually going to be launching. Well, just to get liquidity in the market, we had already decided we were going to have a period of time with no transactions. What we're doing actually is making it so that there's so that the rules for transactions aren't going to be in yet when mainnet launches, and we're going to soft fork in the rules for how Chia list works before transactions start. So it's not that we are going to start work on that. We're almost done with work on that, but it's not finished yet. So that's kind of buying us some time and allowing us to get actual farming started earlier. So we're trying to get that out as quickly as we can.
Yeah, no, we're actually in a pretty good place because we've made that decision. We, lowers the total risk that we have to launch with everything bolted and only the things we already know the work bolted. So we do have a few more things. You can always look on Trello, which is on the GitHub project tab, and you can see exactly what we're looking at to get things done and going.
Well, you guys got a whole lot of things in that list. You've a lot of exciting new stuff for Chia in the works.
Some of those things are like 3R1, so it's not as bad as it looks. But let me ask this: what do you plotting guys have to ask for Bram and I?
Yeah, I mean, the one thing for, we kind of touched on it, was like the plotting format. Just as being somebody who's dealt with high performance SSDs and stuff, it seems like most people storing high performance storage do it in a database format. So, yeah, how did you guys end up on the final like plot file versus doing it in a database versus complexity?
Yeah, so it's a flat file, right? It's a database in the sense that it has its own designated format. It's all about getting it as compact as you possibly can. And a lot of the work on it, I mean, this might sound a little silly, especially given what we were just saying about K32s, but a lot of the work really before we did our plotting implementation competition was on getting the format good. And there's this subtlety where there's like back pointers between tables, and those were like using up like 8 bits per entry. And we got that down to basically half a bit per entry by algorithmic stuff. What we have, and that actually impacts consensus because there's a question of how much credit you get for the K that you're using, and that should be fair across different Ks. And so that value impacts that. So it turns out it's K plus 1/2. Is a value that's used there. Anyway, a long time spent on that formula. It really is just as compact as it can possibly be. It's nothing even vaguely resembling like some general purpose format or something. It's like super bit level squeezed down into nothing kind of stuff. And like we've had notes about how, well, if you did blah, you could make these more compact to the tune of like 0.1%. There's a few notes that we put in about things like that. The one big one would be if you did a Hellman attack on it, which could probably basically eliminate your first table from it. It just compactify your first table down to nothing from the finished format. At the expense of, let's say, running basically doubling your plot time, probably something vaguely like that. But that will be doable. It'll be possible to do that for a plot that you've already finished. So if you finished a plot today and you want to compactify it further once someone's implemented Hellman attacks, then you'll be able to do it then. We actually did implement Hellman attacks, but the way we implemented them totally fails unless you have like an amount of memory equal to like the entirety of table 1, basically. So more algorithmic magic needs to be done in order to do that. Is like not multiple passes.
I see. So they recreate some of the magic in table 1 with the other tables or something?
No, it's just table one. It just compactifies table one by itself. There's this trade-off where in exchange for using more computational power, you can have less space. So like doing something where you have to do like 1,000 operations instead of one in your CPU and getting like a factor of 1,000 in table one, that's clearly worth it, right? You just eliminated your table one. But as soon as you go for more tables, that trade-off becomes much, much less favorable. It's now compactifying more tables, but it algorithmically doesn't work so well. So basically, the optimal way of using it in practice is probably going to be somewhere between 1 and 3 tables that you do it on. Definitely you could use it to almost completely get rid of table one, and that's a real optimization. 2 and 3, it's dubious. The first 4, it's just not going to happen on no way. Yeah, so that's something we'll work on, eventually. The next up on the how could you improve the format to get it even more compact thing is there are these things where sometimes you have something in one table that has children but no grandchildren, and so it's silly to just put the child in the next table. You can just inline it into the table after that. That can get you like 2% in principle, sort of. That's actually a lot more work than even a helmet attack to implement. So that's way down the list of stuff for us to work on eventually. But in the vein of these things, the format is basically compactified almost as well as we could possibly make it be compactified. We gave a whole list of known potential ways of compressing it further, and 1 or 2 theoretical. We're unsure of whether there is actually a way of getting this last 0.5% even in principle using this known thing. In a few places in it, given what a complete brick wall this has been to everybody else, maybe we've been a little bit obsessing on it excessively ahead of the game. But yes, it's all about how can we get this squeezed into as small of a space as it possibly can, so everyone's on an even footing here and no one has an advantage just because they have better algorithms for doing this. And it's still not at its terminal point. We know that at a minimum there's doing helmet attacking on it. But yeah, so just FYI, at some point in the future, you might want to take like most of your plots and do this other operation to compactify them further. It might be a thing that happens.
And so if you ever wanted to wonder why it took a little bit of time for this to launch, there's a hell of a lot of thought that had to get done and tested and actually implemented. If you're throwing up an ICO that doesn't have much work in it, you can get it done in a few months. And if you're trying to figure out how to make sure that you're actually future-proofed against the entirety of the PC architecture infrastructure, well, you got to think about it a little. There are a bunch of great questions about stuff that's not plotting. I apologize if I don't get to those. We'll get to those in other cocktail hours. We're trying to stick to plotting. I think a good question came in on plotting. What's a good starter resource for server grade configurations? Is there something like Basement Data Center for Dummies?
The plotting hardware channel. No, we've been trying to put as much as we can in the wiki, but there are some good resources like there's like some YouTube channels like Serve the Home and stuff that have like good resources on servers and how-to guides and 101. There's one called like Craft Computing or something like that on YouTube. There's some good stuff, but yeah, it's funny. I see all these questions about, hey, can I take this brand new NVMe drive and put it on an 8-year-old server? And it's like, well, the first NVMe drive launched in 2014, so no, it's probably not going to work. I could, as somebody who ran validation and testing for Intel, I can tell you, probability that works is not good. So I would start out with like, if you're buying a server, generally these server guys qualify like certain components in the server specifically for compatibility. That when you put it in, it's going to work. Like Dell spends a meticulous amount of time doing that. Like when you buy a Dell SSD or something like that, you put it in a Dell server, it gets all the functionality and works. So yeah, mix and match. When you start doing that stuff, you're going to see bugs and you'll see issues and weird stuff. But that's how you learn. You start with something and you start playing around with it, and you'll get better as you start hacking away at the hardware.
I mean, I try to just stay away from rebranded stuff I bought off eBay. So I wouldn't buy a rebranded Intel SSD, rebranded by Dell, rebranded by HP. It's like the Dell rebranded ones, you only can upgrade the firmware if it's installed in a Dell server, and things like this. It's just very annoying.
So Kiwi.
Right, yeah, and people ask me about the vendors and whatnot. You know, I'll give you my real answer, which is go with the most popular guys. You know, I can vouch for Intel stuff because I know it, but Samsung and other guys, the ones who are major deployers of Flash, generally buy them versus some like little tiny guy. I can tell you just based on the comments in the firmware about the terabytes written and some of the way these consumer guys manage their firmware is just abysmally bad. Like I
mean, your 3710 is just the best SATA drive ever made. Period.
Michael's a big proponent of my one of the products I worked on back.
You can't destroy it.
Yeah,
it's
indestructible.
Hey,
I mean, I think Farming Guy fried one on a
Hey, I have a question related to that. Actually, who's doing fluorocarbon cooling on their things? Like, are people doing that?
No. Yeah.
Well, Gene, we're doing it, so why don't you tell them about it?
We're heading there, but that's for Time Lords, not for plotting.
Oh, that's right, Time Lords.
Right.
Although it's funny, the plotting process is pretty frequency sensitive, right? So if you have a 10-year-old CPU that's plotting at 2 gigahertz versus a brand new AMD or Intel that's plotting at 4.5 to 5 gigahertz, you're going to see a massive difference in plotting speed. And
but I think that's the thing that a lot of users don't realize, which is there is the core clock and then there is the boost clock. And if you're plotting one plot, you're plotting that at the boost clock all the time. And if you start to load your system, you're plotting at core clock, which is often 25% or even below the boost clock. And that is what's causing a lot of the slowdown, and you can't just blame it all on your disks. It's really the CPU, it's running a lot slower.
So I was going to say, H, and somewhat related, almost everybody thinks you got to use SSD. We talked about it a little bit, but can you tell us more about like what you're getting away with not using SSD?
Yeah, I've got a couple of plotters. One runs just a standard 2.5-inch SAS SSDs. It's obviously not as fast as HDDs. They're not as fast as the SSDs, but 24 plots at a time, and they carry on nicely.
I've rented because I find it a very interesting topic. So I had rented a server a couple of weeks ago, cloud server by used to be Packet, now it's a Equinix Metal. It's I think there were 8 or 6, I think 8 hard disks in there. You get away loading that system fully with 30,000 seconds per plot on HDD, SATA HDD.
That's not bad.
Yeah, you guys, that 3x speed up that you guys did on the plotting algorithm, basically enabled some low-end hard drives. Like before, in the alpha, there was no plotting on hard drives. It would have been, 10x, 20x the times for plotting. So it's good that the work that you guys have done has really helped, the low-cost hardware guys at least get something being able to get plotted. Obviously SSD is going to be faster, but being able to at least do some plots on hard drive is very, very good.
Yeah, I think there was a moment where you got rid of millions of seeks. I believe that was really very good for the hard drives.
Oh, it wasn't seeks. It's number of passes over the data that it's doing. It was dramatically lowered.
From a monitoring point of view, I saw seeks, millions of seeks.
Yeah, because it was doing the read again, right? So it's taking a pass, reading it up.
The data list, so there's seeks.
So.
Yep.
Yeah, it wouldn't. That's interesting that you say that. I mean, we did a number of improvements.
Mariano got rid of those. I remember the conversation that we had.
Yeah.
If Mariano's asleep, otherwise he'd probably be on here right now.
Yeah.
Let's see. Let's talk about the flags. What's Bitfield? What's buckets? What's stripe size? What should I touch?
Buckets is always 128. Do not change it. Always set it.
Stripe size is always 64, whatever it is. Don't mess with it.
65536.
Yeah, actually, Mariano, is that how you pronounce his name?
Yeah, Mariano.
Mariano.
We're talking about the buckets. So SSDs are good at random IO, right? That's the it's when you in Flash is when the core bottleneck of Flash is to write to SSDs, you have to erase the block before you write it, and you program in pages, erase in blocks, and there's this whole garbage collection process and stuff. But an erase block is anywhere from we'll say 50 to 100 megabytes, and these writes, the bucket sizes, 128 bucket size is like 7 megabyte files. So the difference between like 3 megabyte file and a 7 megabyte file to an SSD is nothing. I mean, it's literally nothing. We write in 16K pages. It doesn't matter, So the more buckets, actually, the better. And for SSDs, the smaller you break the files into the IO and the less DRAM you use. So basically, when you scale the buckets up, you scale the DRAM use down. And on SSDs, most mainstream SSDs can handle almost any type of low block size, like all the way down to 4K, 4 kilobyte transactions. So there's almost no reason, as Kiwi said, to not use 120 buckets, which is the max in the software today.
Yeah, you use the 128 buckets. It's the minimum amount of RAM you need. You can run more plots in parallel. And one of the things I found doing some testing is there's the optimal amount of memory you need to do all quick sort, but you can go even lower than that if you want to do more plots in parallel. And the penalty performance, if you get right down to bare minimum RAM, it's like a 10% performance difference. So if you really want to go lots and lots of parallel, yeah, you can do a lot of quick sort, but you can basically double the number of plots you're doing at once.
So Bram, I think it's probably worthwhile to explain bit field versus non-bit field.
Yeah, it was interesting that you said about SSDs. So SSDs, like when you write a small section, it has to like read the whole region it's in and then rewrite out that whole thing again with that small section change. Is that?
And it's full, right? So it's like a parking lot. When so if the drive is empty, the algorithm is very easy. The SSD finds the next free erase block and it writes the pages right there. If the SSD is full, that's where it gets really complicated. It has to do a read, modify, write on every single write that comes in. And in SSD world, we call that write amplification. And the higher the write amplification, the worse the endurance, because you write more to the flash and wear it out faster.
Yeah, and it doesn't have good defrag from our nice, clean, just like write out a whole sequential thing, destroy the whole block of things at once.
So that's good. So the more sequential the workload, the lower the write amp is. And this is another one where in the chat, people often look at this terabyte written on the drive and say, okay, this is the math of when my drive's going to die. And that on enterprise drives, that's not how it works. You have a number of program erase cycles for every NAND die that you can program and erase the cell before it wears out. And depending on your workload, whether it's sequential or random and how full the drive is, or whether you have trim enabled or not enabled, that determines the write amp factor, which determines your endurance, which determines the wear out number of plots you can get per drive before it wears out.
Okay, so that's really interesting. Yet even more deep magic. What's going to determine performance here? So the question of what does Bitfield do? So basically, the format from an algorithmic standpoint, what's going on with the format is each table, each entry into it has like 2 pointers into the table before it. And so when a challenge comes in, the response to the challenge is actually 64 things. So it like doubles every table that it goes through, the stuff that it's getting. Sometimes there are things that have no children. And there are sometimes things that have children but no grandchildren, or grandchildren but no great-grandchildren. Obviously, the probability of this goes down with each generation you get to. But you definitely get the plotting process in a nutshell is it generates everything going forward in its first pass. It then back propagates the non-existence of children all the way up to the very first generation in table 1. And then finally, it does a compression step running forwards across the whole thing. And some aspects of these are kind of munged together. What it's doing on a bit field is instead of like sorting all the things to be in order of what actually gets used, it just generates a bit field of everything from the previous table that was ever accessed. So that's really, really tiny because it's 1 bit per entry instead of, K bits per entry, or more than K bits per entry. So that can generally be kept in memory, depending on stuff. And if you can keep it in memory, it saves you a pass over a whole bunch of stuff, and gets you some performance, assuming that your random accesses to check the bits are fast, which they should be if it's in memory. But that's also complicated because relative to CPU, memory lookups are expensive. So again, all kinds of crazy complicated stuff going on, but that's what that optimization does. It saves you passes over disk. It's not a huge optimization just because it's not, it turns out it's only a small fraction of all the operations it's doing that it impacts at all. So it doesn't make a huge difference there.
So Zernox, what's that end up looking like in practical day-to-day?
I see. So on my testing I did with that rented servers using HDDs only, it's a good 10-15% better.
Oh wow!
Using Bitfield, yeah. So
Okay.
it's like a 34. I can post if I find time to present this data nicely. I can post a summary, but I think if I don't mess it up in my head, it's like 34,000 versus 32,000 seconds per plot.
Yeah, our implementation is probably doing a much better job of optimizing for HD than for SD, just because that's kind of the mental model I was working off of, and sort of the most important target that I've been thinking about is just some consumer person wants to set up a plot on their hard drive and they run it. So that's a lot of what the stuff is optimized for. It's also the easiest to think about.
Yeah, I also want to add in on the practicalities that you'll find that using Bitfield sort is going to take a little more memory than using non-Bitfield sort. And so the trade-off in parallelism may be very different. I think Kiwi wanted to add that.
Yeah, Bitfield requires about 75% more RAM. So if the trade-off's worth it, go for it. If you want to go for lots of parallel, turn off Bitfield.
Yeah, it actually requires an amount of RAM that's linear on the size of the plot, but since everyone's using K32, this is a constant. So,
I mean, the thing that most of us, I think, saw is that enabling Bitfield using any flash drive, it makes it a lot slower.
Yeah,
Right.
But it might not be related to Bitfield, but I think this is an area to look into.
it's probably if we didn't adjust RAM. We had Bitfield.
With ISO memory, it's about a 20 to 30% worse plotting time on SSD with Bitfield enabled versus without.
Oh, it's also going to reduce wear on your SD if you use Bitfield.
Yeah, it's about 12% less total writes.
Yeah.
That's slow.
Yep. So there's trade-offs everywhere. Welcome to real computer
we're
science.
Not really sure. Like crazy things happen when you're doing SD because sometimes the bottleneck will be CPU rather than disk. If you're doing it, so it wouldn't shock me if it turns out that Bitfield is worse for SD because you're doing random access lookups in memory, and random access lookups in memory are actually slower than continuous throughput on sequential things with your SD. That's entirely possible.
Yep. So we're kind of running out of time. I'm going to go a little over if everybody's okay with that. There's 3 different things I'd like to do. The first one is, Bram, can you share, why we say someone might want to delete a plot and how we're thinking about that right now?
Oh yeah. So this is a little bit, it's really ridiculous, the skullduggery that is part of the everyday when you're designing consensus algorithms. You really think about insane, crazy things. So there is this in principle attack where if you have a network where it's so dominated by a small number of whales that there are surprisingly long periods of hours where if you knew all the keys of all those whales, you could do a foliage reorg of that. So in Bitcoin, when you make when you make a block, once it's buried, it's really buried. When you're doing proofs of space, there's really 2 kinds of being buried. On the one hand, something can be buried in that it's impractical to change who the plot winners are going that far back. But then in the interest of stopping grinding, all the malleable things aren't factored into the upcoming challenges. They're signed off on by the people who won the previous ones. So if you get a cabal of these signers who all get together for the past whatever, they can just make up a new version of the history up to the point where they don't have the keys anymore. So it's not unreasonable to have a policy to avoid anyone getting any funny ideas about putting a gun to your head and trying to make this happen. Now, how ridiculous and crazy this is, and whether this sounds like me being paranoid, I don't know. But if you delete the plot, if you delete winning plots, they're just gone. They're toast. They no longer exist. So particularly for plots that win a transaction, if you're a big enough whale, it's kind of I'm saying best practice. It's nice, it's polite, it's a good idea. If you have like thousands or millions of plots, that if a plot wins, you then delete it and replace it with another plot afterwards to make sure that the keys for that are well and truly deleted, and there's just no way anyone in the universe could possibly reorg past that depth in the foliage. If you're not a huge whale, don't worry about it. Even today, if you are a huge whale, don't worry about it too much, but it's polite. It's a good idea at some point in the future to do this.
So with that, let's run around the panelists. Is there anything you think we didn't cover well enough? I know, for example, Derek, that there's questions a little bit more about your strategy. So let's start with H and go to Derek, and then Zornox, and then Storage Jam.
I've got nothing offhand. Mental blank.
All good. Derek?
What was the question about my strategy?
Yeah, people really like to know more about your kind of, small, cheap, multiple computer strategy.
Yeah, okay. So I've actually built my first server standing next to me. I had to try it, right? It's an old 2014 dual Xeon DDR3. It's here, so I'm gonna try it. But when Chia started off in the early days, there was no real possibility of doing all these parallel plotting and all that. The early days plotting was really tough, right? So you were just grinding it out, cave 34, cave 35, cave 36, and so that I stuck to that hardware. But then for me, I just find it easier to use than struggling with large machine that is plotting a lot of things in parallel. I get less. I don't plot very fast, but it's very consistent and it's very user friendly. I don't have any errors. I don't have any downtime. I can plot less. I can plot more. So I can manage the energy usage much better. I don't have to run a large machine, large CPU, energy consuming server. I can manage it that way. So my computers is very simple. They are 4-core to 6-core processors. Each computer, they are not in they are open frame mount. There's no boxes or nothing like that. Each one has got a small little bay with that. It's got a $35 LSI 9240 RAID card on it, and the machine boots with a 1 terabyte SSD Micron. And then on the RAID card, I have 2 3710 Intel Enterprise drives and 4 terabyte SAS drives. So what I found early on is there's a lot of time that's been wasted, in actually moving the file to the destination. So I plot 2 to 3 files, and then the destination is a RAID 0 of 4 SAS drives, right? This gives a total of 16 terabytes. So the file copies much faster. It sounds insignificant, but when you plot 10,000 plots, if you accumulate all the time that the thing takes to copy at 100 megabytes per second, it actually a lot of time lost there. So mine moves into that, and then I would take a 16 terabyte, farm drive, and I will copy the files over to that while the thing is plotting, and move that drive then manually into the farmers, and that's how I do it. And I can plot 16 to 20 terabytes a day doing that.
That's awesome.
My farmers are Threadrippers X399 with 9 to 40 cards flashed with the 9200 firmware. So it's just normal HBA, doesn't have the mega RAID on it, and it's just plug and play. All the farmers are custom built, right? They don't. I'm sitting in the room now. There's 1.4 petabytes running here, and there's no noise. They are all passively cooled. They are basically noise free.
That's awesome. Zornox, anything we didn't catch on?
Don't go and just buy hardware. Just really, unless you don't have just anything. I know from a user, I won't disclose his name because I haven't discussed this, but we have chatted a lot, and he has also done a very similar strategy to you, Derek. Ended up with dozens of small machines. So if you're gonna buy, I've started my first plotting on Intel NUCs that I still had, like 4 or 5 year old NUCs. There was already a PCI version 2 NVMe drive in there, and it was fine. It was almost a terabyte, maybe 0.7 terabytes a day with the latest versions. A lot slower, obviously, with early versions. I have an old 4770K. That was I think that was maybe the best Intel CPU that ever was, that I bought in 2013. It really didn't get much faster since then from a single core point of view. If you buy a CPU, worry less about the cores. Per core, you need to have I/O. So it doesn't help you if you have 16 cores, but only 3 NVMe flash drives in there. You can't utilize all these cores. Worry more about the best single core performance that you can get. I have 8-core CPUs mostly. I'm much happier with that. They clock a lot higher. The most recent 58X that I used to crack the 12,000 K seconds mark. It's a little below that.
I'm coming after you.
You can I've overclocked that CPU with a regular Corsair liquid cooler to what was it, 4.7 gigahertz all cores. Much happier with this if your desktop, and you know what, that computer, if you're done plotting, you can use it as a gaming machine or office computer, or you can actually resell it pretty well. I think that is maybe one of the most important reasons for me to not buy server gear. I have a bit of a fear. If I buy 5-year-old server hardware or so, I'm not going to be able to resell this if I don't use it anymore.
Yeah. John Michael?
Yeah, no, we see a lot of questions in the chat and Keybase of like, okay, people are trying to get like the perfect config before they start plotting. Like these guys said, just like grab anything and start plotting and learn the process, learn the tool. You know, you don't have to have like high-end stuff to start it. And then once you have an understanding how it all works, you can start putting it together. Like, you know, theoretically, the best plotter would be you have super high frequency single cores, you have lots of cores, you have lots of DRAM, lots of temp space, and you have complete parallel processes. And you know, we've tried to do a good job of posting all of our machines on the wikis. We have a couple Google Sheets pages with all the machines and times. You know, we're trying to make it very open to like, you know, figure out what we're all doing, just so everybody kind of knows what to build and where we're at. And so yeah, feel free. We're all up on Keybase pretty often.
I mean, maybe one last comment here. As fast as plotting is, it's still pretty slow. So it's better to start plotting slow versus just waiting around not plotting, because the one thing you cannot buy is time.
That's right.
Well, also a lot of plotting is about cost, and the cheapest stuff is what you've already got sitting around. So
yeah.
So for everybody to know, when you're watching the replay of this, especially, we're almost all here. One of us is usually there 24/7, 365 effectively. And the few people who aren't on this call are awake on different time zones as well. So you've almost always got a plotting expert somewhere around Keybase. So everybody knows Hamish is KiwiH. Derek is Farming 101. Michelle is Zornox. Jean-Michael Hands is Storage JM, and you know me and Bram. And I've got my penultimate question. And I told Bram about this as we were pulling together, and he's like, "Oh, I have questions." And I told all the panelists that, and they went, "That's not scary." So, Bram, do you have any other questions?
Yeah, I do. Well, my main thing is this sort of, I mean, people have said a whole bunch of really interesting, indicative things about performance on SDs and stuff. I actually, everyone has observed, I get really excited when I talk about plotting optimizations, so all kinds of exciting stuff there, although unfortunately I'm not going to be working on that again anytime soon. The big question observation kind of thing I have is I notice everyone here is talking about like really acquiring and plotting on drives. And no one is talking about, no one is owning up to doing it on storage media that they have for some other reason. We do know there are many, many enterprise places that have lots and lots of over provisioned storage, which might, if they start getting in the game, that could really, wreck the work difficulty on our network. We make no promises about what's going to happen in the future. So a series of questions related to that. Do people know of that happening, or have any idea of places that might do that, or why we're not seeing anyone talking about doing that now? And if that might happen, might some of people with plotting rigs have plans to just like bring their plotting rig over to someone else's thing and plug it into a wall and spit out the plots there? I mean, I could definitely see places who have over provisioned storage, either, shall we say, officially or unofficially starting doing farming on a whole bunch of that. Curious how that might start happening.
And Kiwi, you're completely allowed to do an advertisement here.
Oh, yeah.
No, I've got nothing to advertise. Although, yes, plotting as a service does exist. It is legit, and you can securely offer plotting as a service, and I do.
Yeah, and remember, the key piece to plotting as a service is that the UPS truck has tremendous bandwidth.
Oh yeah,
Good eye. Yeah, and we, honestly, we probably would have seen more people asking questions in the chat if there were, other large, people that already have storage trying to do some plotting. I think it's very easy once the economics happen, once the mainnet launches, once it's trading on an exchange, and people could say, "Oh, I can plot this much and make this much money." People think in very total cost of ownership like ways. They're going to say, "Okay, here's my investment of CPU, and I'm going to get it back in coins. That's great. Let's do it." But right now it's so, people are in the early investment stage. So it's hard to like materialize some of that, excitement, which is exciting for us, the early adopters, but the people that are, haven't heard about it yet are going to be much more excited when they have a price tag on it,
So we've gone about 20 minutes over, and I want to leave it a little short just because the replay is something I think I want to make easy for people to go watch and catch. And some of the best content, unfortunately, is here at the end. But my ultimate question for everybody in the room is, and I will say it this way, everyone here has better Bayesian priors than others. How much net space will there be 24 hours after mainnet launch? And I'll tell you that we're thinking about launching mainnet at about 6 a.m. Pacific time, so they can be pretty fair around the globe and everybody's, able to be awake. We're sorry, Australia, that it'll be 2 a.m. But so we'll start with H. We'll go then to Derek, then to Zoranox, and then to John Michael.
my estimate has always been 100 petabytes plus.
Derek,
I was 50 to 60.
Zoranox,
Beyond the 50.
350. Wow, there's
Below 50.
150.
Below 50. You have fixed the bug that estimated it 2x the amount. So I think very short comment. People throw around petabytes like terabytes. It's not like that. It's 1,000 times more.
Okay, so I apologize. What is your actual prediction again?
50, less than 50 petabyte.
Less than 50 petabytes. Great.
Yeah.
And storage.
Well, I'll take my best sports betting. Like I'll take the over on 60. So I'll take 80. Yeah.
So I admit I'm still thinking it's like 60-ish. That's where I'm at.
I'll
Bram.
take the over.
I I have no idea. I don't think in constant values. I count 0, 1 to infinity. The thing I'm really curious about is whether there's an immediate bump on mainnet launch. If people are going to have some amount of storage that they're just not attaching to testnet that immediately shows up when mainnet launches.
I think we can predict that that one's definitely true.
Some amount, right? But yeah, it's risky to just not test it. So yeah, we've been all monitoring every single launch to try to see what the spikes are and meticulously try to guess what the
Yeah, and it looks like the blockchain has now gotten to a point where it should be moving at normal speed. So
I'm farming right now.
It makes life easier for us if there isn't a big bump on mainnet launch. Our plan is to make it so that the initial work difficulty for mainnet launch is set at somewhere between 1 and 2x what testnet has stabilized on at that point, and let it settle out reasonably quickly. We'll see how that goes.
Partially.
A bit of a comparison I use is the 10900K, the Intel CPU, right? It does 4-ish terabytes a day. So it takes 250 days for that CPU to put the petabyte. To put 30 more petabytes, you need 30 of these machines doing this for 250 days. And it's a lot of compute. It's really a lot of compute. You can have 10, 20 of these. You're going to deal with heat problems in your house that some users can talk about. It's not easy.
Yeah.
Well, Michelle, as a comparison, I used to do coal coins, BHD. I could plot 100 terabytes in a day. The BHD network had 800 petabytes.
Yeah.
So.
Yep. Well, gentlemen, look, thank you. Go ahead. Sorry.
I think that the surprise is going to come from not the whales or the large players. It's going to come from the 100 terabyte guys.
Yeah.
Possibly, yes.
There's a lot of 100 terabyte guys that's not farming on the testnet.
I plan on my 40 showing up. Hey, gentlemen, thank you all for taking some time out on this afternoon. We'll do this again on a different topic, but it's been a blast. It's time for a refill.
Yes.
Oh, it is.
Yep. Again, it's February 19th. It's about 5:25. Any question we didn't get to, happy to answer them over on testnet. If they're support related, plotting related, plotting hardware is kind of the advanced channel for plotting. If it's more about energy consumption or what do you think about the project, general is actually the right place for those kinds of questions. And many of us will be online through the evening. So thanks everybody. And thank you guys for helping out.
Bram, Gene, Ellis, thanks a lot.
Bram,
have a good weekend, guys.
Thanks, everybody.
Take it easy.